Hello everyone, my name is Jasmine from Electronics and VLSI. My roll number is 23118010. My topic is FPGA design flow. What is an FPGA? FPGA stands for Field Configurable Gate Array, which is basically an electronic device, basically a chip where we can design our own hardware circuit using code. We write a code and it is converted into a custom hardware. FPGA contain logic blocks, flip-flops and interconnection like how they are connected. We write HDL code and our FPGA behave like custom hardware. We can design many circuits like half adder, full adder, traffic light controller, processor. Once programmed, our FPGA works like real hardware circuit. In FPGA design flow, we define step-by-step process in which we can convert our idea using code into working hardware circuit on FPGA. These are the steps for FPGA design flow. Steps include design specification, design entry, functional simulation, design synthesis, implementation, bitstream generation, and FPGA configuration. In first step, design specification, we decide what we want to build. We decide speed, power, and everything else that are necessary for specifying our design. In next step, we write code for our design like what we want to build. Next, in functional simulation, we simulate our design by writing test bench and giving various inputs and checking a truth table like if our output is correct corresponding to the given inputs. In next, design synthesis, we convert our code into logic gates. Our design is converted into gate level netlist. In next step, implementation, our components are placed on FPGA and connection is decided between them, like how inputs are connected to each other. Next step, bitstream generation, a configuration bitstream file is generated. This is basically a binary file. And next, the file is uploaded on FPGA and an FPGA board is ready. Now we will see this FPGA design flow with the help of an example of half adder. In first step, design specification, we write the steps like what we want to build. Like in this, we are building half adder. We are taking out inputs A and B and we are checking outputs corresponding to them, sum and carry. We write first function like we are checking sum. For A and B, XOR gate is needed for sum, and for carry we need AND gate. In this step, we define truth table, and in next step, design entry. In this step, we write Verilog code. In this example, we are using data flow model for specifying our design. We have given module name half adder. Input A and B are taken and output sum and carry are taken, and logic is written corresponding to the input. Like for sum, A XOR B, and for carry, A and B. This code describes how our hardware should actually behave. In next step, functional simulation, we test the design without hardware. Like we give input. In this, we are giving input A is equal to 0, B is equal to 1. And for these input, our sum will be 1, carry will be 0. For input A is equal to 1, B is equal to 1, sum will be 0 and carry will be 1. We match the outputs, and if the outputs are matching, then our design is correct. In the next step, design synthesis, our code is converted into hardware logic, like AND gate is created for sum and like AND gate is created for carry and XOR gate is created for sum. So our HDL code becomes actual digital circuit. In next step, implementation, this step basically includes mapping the design into hardware. In this step, my steps are translate, map, placement, routing, and interconnection. Like in this example, XOR and AND gate are placed inside FPGA logic blocks and connection is made between them using wires. Now the design is physically arranged inside FPGA. In next step, bitstream generation, a bitstream file is generated. This file contains binary data that configures FPGA board. Like this bitstream file defines where the XOR gate is present, where the AND gate is, and how these gates are connected to each other. In next step, FPGA configuration, we finally upload the bitstream file uh, and give inputs, like we define for inputs A and B we are using switches, and for outputs we are seeing them on LEDs for sum and carry. Now the FPGA behaves like proper half adder. Now we will see this proper FPGA design flow by running the code in VIVADO and seeing it on FPGA. And firstly we will make a project and write code for our half adder. Like in this we will make a module half adder, and we will specify input A and B, output sum and carry, and write the logic for sum and carry. We are using here data flow model for writing the code. Next we will write the test bench for simulation. In this we will give possible input cases and check if we are getting the desired output corresponding to them. We will click on run simulation on left side of the VIVADO. After this we will get the proper waveform that is showing the output. Like we can see in waveform, if we give 0 0 input to A and B, then we are getting sum and carry 0. If we are giving A is equal to 0, B is equal to 1, then sum is equal to 1 and carry is equal to 0. If we are giving A is equal to 1, B is equal to 0, then sum is 1 and carry 0. If we are giving both of them 1, then we are getting sum 0 and carry 1. Next we can also check the proper elaborated design that are on F by clicking on elaborated design and then clicking on schematic. We can see that for input A and B we are AND gate is made for carry and XOR gate is made for sum. Then we will write XTC file. In this file we will write which ports we are actually using. Like for inputs we are using 2 switches, and for output we are using 2 LEDs. On one of the LED we will check sum, and on second LED we will check the carry. We will give possible inputs using switches that 2 we are using. Firstly we will we will click on run synthesis. Then after that we will run simulation, then generate bitstream. Then bit file will be generated, which we will upload on FPGA board, and we will see that if we give different inputs using switches, then we are getting different outputs and different LEDs are glowing. Now we can see in this video we are giving different inputs for A and B using the switches, and we are getting different outputs corresponding to them. Like we can see different LEDs glowing, in some cases for sum and in some cases for carry, based on inputs we are giving through switches. Thank you.